Why students can solve problems but cannot explain them? The strange gap between getting the answer and understanding it. There are students who can solve difficult problems quickly, but completely freeze when asked to explain how they got the answer. At first, this seems confusing because solving the problem should mean understanding it. But after seeing this happen repeatedly in classrooms, it starts to feel like those two things are not always the same. Someone can arrive at the correct answer while still struggling to explain the reasoning behind it. This is interesting because schools often treat correct answers as proof of understanding, even though explanation requires a different level of thinking entirely. Why memorization can look like understanding, a lot of modern education depends heavily on repetition. Students practice the same problem styles over and over until the steps become automatic. Eventually, the process feels familiar enough that they can complete it quickly without consciously thinking through every part. That system works well for grades and test performance. But this raises a question. If someone learns a process without fully understanding why it works, what happens when the problem changes slightly? Usually, that's when the confusion appears. The difference between recognition and reasoning? One thing teachers notice often is that students recognize patterns faster than they understand concepts. A student might immediately know which formula to use because the question looks familiar. But if you ask why that formula applies, the explanation becomes uncertain. Recognition is faster than reasoning. The brain likes efficiency, so once it recognizes a familiar structure, it tries to solve the problem as quickly as possible. That shortcut helps during timed tests, but it can hide weak conceptual understanding underneath. A situation that happens constantly in school. I've seen this happen during math classes a lot. Someone solves an equation correctly, but when another student asks how they knew what to do, the answer becomes something vague like, "I just knew," or "that's how we learned it." Sometimes the person genuinely cannot explain the reasoning, even though they solved it perfectly. That moment says a lot more about learning than people realize because explanation forces the brain to slow down. Instead of relying on automatic pattern recognition, why fast learning can sometimes become fragile learning. Students are often rewarded for speed, finishing first, solving quickly, moving through material efficiently. But speed can create a strange illusion of mastery. If learning happens too quickly, students may skip the deeper reasoning stage completely. And the difficult part is that nobody notices the weakness immediately because the answers are still correct. The problem only becomes visible later when students face unfamiliar questions that require flexible thinking instead of memorized procedures. The role of educational structure. Part of this issue comes from how schools measure success. Most tests prioritize final answers more than explanation quality. Even when reasoning sections exist, they are often shorter or less emphasized compared to accuracy. Over time, students adapt to what the system rewards. If correct answers matter most, then naturally students focus more on procedures than conceptual explanation. That adaptation makes sense from a survival perspective inside school, even if it weakens long-term understanding. Why explaining something feels harder than solving it? Explaining requires a completely different mental process. Solving can sometimes happen automatically after enough repetition. Explanation forces students to organize ideas consciously, connect concepts together, and translate internal thinking into language. That's much harder. This is probably why many students suddenly realize they don't fully understand something when they try teaching it to another person. The explanation exposes the gaps. The internet changed learning too. Modern learning environments make this even more complicated. Students now have instant access to worked examples, tutorial videos, AI tools, and step-by-step solutions. These tools are useful, obviously, but they also make it easier to imitate problem-solving patterns without deeply processing the reasoning underneath. Sometimes students become very good at following methods while still struggling to explain the actual concept in their own words. And honestly, that's understandable. The pressure to finish assignments quickly often matters more than fully sitting with the idea. The difference between information and internal understanding. Memorizing information is not the same as integrating it into your thinking. Real understanding usually feels slower, sometimes even uncomfortable. You ask more questions, pause more often, and spend time figuring out why something works instead of only learning the steps. But schools do not always create enough time for that process. There's often pressure to move on quickly because the curriculum itself keeps moving. Why some students understand more than their grades show? Interestingly, the opposite problem happens too. Some students understand concepts deeply, but struggle with timed testing or fast procedural work. They may explain ideas extremely well while making small calculation mistakes that lower their scores. That creates another strange imbalance. The educational system sometimes measures speed and procedural accuracy more clearly than depth of understanding itself. So both types of students exist. Students who can solve without explaining, and students who understand deeply but struggle to perform quickly under pressure. Why teaching someone else changes everything? One of the strongest tests of understanding is teaching. When you teach an idea to another person, you cannot rely only on recognition anymore. You have to slow down and reconstruct the reasoning step by step. That process forces clarity. And this is interesting because many students realize they understand something far less than they thought once they try explaining it out loud. At the same time, teaching can also deepen understanding faster than passive studying because it forces active thinking instead of recognition alone. Why this problem becomes more visible in higher education. As students move into advanced classes, weak conceptual understanding becomes harder to hide. Problems become less predictable, and memorized procedures stop working as consistently. Professors often expect explanation, analysis, and flexible application rather than repeated patterns. That transition can feel difficult for students who spent years succeeding mainly through recognition and repetition. Suddenly, the system asks for a different type of thinking entirely. The bigger question behind all of this: at some point, this raises a larger question about education itself. Is the goal to produce students who can complete procedures efficiently, or students who can actually explain and apply what they know in unfamiliar situations? Ideally, both would happen together, but in reality, systems built around grades, speed, and standardized testing often make that balance difficult. Final thoughts. Students can sometimes solve problems without fully understanding or explaining them because recognition and repetition are not the same as deep reasoning. Modern education rewards procedural accuracy heavily, so students naturally adapt toward the skills that improve performance fast. But explanation requires slower thinking, conceptual connections, and the ability to organize ideas clearly. And once you notice the difference between solving and truly understanding, it becomes much easier to see why so many students struggle to explain answers they can still technically solve. Thanks for watching. Subscribe to learn more.